Okay, I got several homework questions to go over here. All of these involve the function stuff. So here we're given that f of x equals x squared plus 7x, g of x is 4 minus x squared, and we need to find the sum, difference, product, and quotient of those. And just be careful with these because when we do f plus g, always put things in parentheses, okay? So for f plus g, we're going to take x squared plus 7x, and we're going to add that to 4 minus x squared. And this is just a matter of then, combining like terms. So x squared plus the negative x squared, when I'm just looking at like terms here and here, that's going to give me 0x squared. Oh, and my cursor went all crazy. Okay. So we'll get 0x squared, and then we'll have 7x. There's nothing to combine that with, so we'll still have a plus 7x, and then we'll have the plus 4. And now, I don't ever write the 0x squared and stuff. I'm just putting that there to little baby steps to make it kind of obvious when we combine them. So I would just write the 7x plus 4. Now when we do the subtraction, it's the same deal. X squared plus 7x minus 4 minus x squared, but we need to be real careful about the negative sign in distributing that. So you could do this one in 2 steps if you would like, and it might help with sign errors and things like that. The less you have to try to do in your head, usually the easier it is and the less silly mistakes that you make. So when I distribute that negative, we're going to have a minus 4, and then the here, and then the minus and minus there give me a plus x squared. Now when I combine my terms, that's going to be 2x squared. That's 2x squared plus 7x minus 4. Get back there. And then for the product, when I multiply these two things, we're going to have x squared plus 7x times 4 minus x squared. And we just need to use our distributive property and stuff, right? So x squared times 4 would be 4x squared. Then x squared times a negative x squared would be a negative x to the 4th. So remember, when you're multiplying these variables that have the exponents, you just add the exponent, right? And now we have to distribute through the 7x. So 7x times 4 would be 28x, and then 7x times negative x squared would be negative 7x to the 3rd. Now, myself, and then you want to check to like terms and stuff, but I always go in descending order. So x to the 4th is the highest exponent. There's nothing to combine that with. Then we'll have the 7x cubed. There's nothing to combine that one with. The 4x squared, and then the 28x. So that's what we would get when we would multiply those. And then the last one then is the quotient of them. So you would just have x squared plus 7x divided by 4 minus x squared. Now you do want to be careful with quotients because you need to factor them and see if anything will reduce. If you can write it in its lowest terms, the top is, you could factor out an x, that's the greatest common factor. So that's x times x plus 7. The bottom is the difference of two squares, so you get 2 minus x, 2 plus x. Now neither one of those numerator or denominator have a factor in common, so it's not going to reduce. You're safe just leaving it like this. Now when you type that into Mobius, make sure that you put the parentheses around the numerator and the denominator. All right, so the next question out of that section was, we're going to look at composite functions. Now, with the composite functions, you're substituting one function into the other, okay? So for this first one, f of g of x, whatever this outside function is, the one that you see listed furthest to the left. So in this case, f. You're going to start off with that, and that's the square root of x plus 2. Anywhere that you see an x, you should just put a blank set of parentheses and just copy that sucker down. Okay, so I'm going to start off like this. And this is square root of x, so I put the parentheses where x is. And then wherever x is, you have to substitute the other function. So in this case, it's g. So anywhere you have parentheses, you go in and put g of x. And that then is my composite function f of g of x. Now, in this case, be real careful because the square root of x squared plus 9, it's real tempting to try to write that as x plus 3 because x is the square root of x squared, 3 is the square root of 9, but because we have the plus in there, we can't do that. So just leave it as it is, and you're in good shape. Now for the next one, g of f, it's going to wind up being different, but we start off with g, and we put those empty set of parentheses there. Okay, and then anywhere that we see the x, and that was just the x squared. And then again, the inside function is what goes in place of x. So f would be the square root of x plus 2. Now I could easily go ahead and simplify that one because I could multiply that out if I needed to. Say, okay, well, if I do some scratch work off to the side here, and I have square root of x plus 2 times square root of x plus 2. When I distribute those, square root of x times square root of x is just x. Square root of x times 2 is 2 square root of x when I multiply there. Then I got to distribute through the 2, so 2 times square root of x, and then 2 times 2, and I combine those like terms to get x plus the 4 square root of x, because those are like terms here. And there's nothing to combine the 4 with, so that's just going to be a plus 4. So if I simplify this one, we have x plus 4 square root of x plus 4. And those are my composite functions there. Now the last one was we're given these two functions, and again, it's composite functions, but it's just a different notation. So with a here, this is the same thing as g of f of x. It's just written differently. That little circle still means composite function, and I'll do it exactly the same way. So okay, for g is negative 1 over, and then I just need those parentheses. So okay, I need to substitute the f, and so that's square root of 2 minus 12x. Okay, so that's part A. Then part B is to find the domain. So I always do the domain for composite functions in 2 steps because it makes a little bit more sense to me to do it piece by piece and I don't miss anything. So what happens is you have some set of numbers, and this is the domain where you start off with here, okay? And then you apply, in this case, f. And that's the square root of, was it 2 minus 12x? Okay? And then you get some kind of outputs, okay? And then you take those and you apply your next function, g of x, which was negative 1 over x, and you get some other outputs, right? When you do the composite function, what's happening is that you, okay, that you take each input and output one step at a time. If you really broke it down and you looked at g of f of x and I wanted to evaluate it, let's say at at x equals 1, okay, then I would look at f of 1. Okay, so in this case, we get the square root of 2 minus 12, and that's not going to work. So I'm going to do what, you know what, let's do x equals 13. Okay. So, no, 13. Okay, so you know what, I had x equals 1, but we're going to wind up with the square root of a negative number. So this is not in the domain. Okay? Which is kind of applicable to what we're talking about. But let's say if we wanted to evaluate it, x equals -1. So if I look at f of -1, that's square root of 2 minus 12 times -1, which is square root of 14. Then I would apply g of x with that number. So we do g of square root of 14, okay, which would be 1 over -1 over square root of 14. That's how you evaluate in baby steps a composite function. You put a number in for your input into the first function, the inside one. Then whatever that output is, you use as the input for the next one. So it's a two-step process. So if I want to find the domain, then the first thing is I've got to figure out what the domain, what my inputs are to begin with of my starting function. Okay? So I know because that's a square root function, we're not allowed to have negatives under the square root. So I'm going to start off by saying, you know what, 2 minus 12x has to be greater than or equal to 0. So I can subtract 2 from both sides. If I do that, I get -12x is greater than or equal to -2. Then I'll divide by the -12. Now, check it out. Since I'm dividing by -12, I have to flip my inequality symbol over. And then I reduce, so x has to be, to start off with, x has to be less than or equal to 1/6. Now, the problem is I get a bunch of numbers over here. So I start off, and all of this thing is from -infinity to 1/6, including that. But on the second piece, the x can't be equal to 0. So I also need to know where, for what value for x is going to give me something 0 there. Okay? So the question is then, and it becomes, okay, when is f of x equal to 0? Because that would be a problem. Because remember, that's what we're substituting into the next function. Okay? So when is f of x equal to 0? So when is square root of 2 minus 12x equal to 0? Well, we go through the same solving process here. We can square both sides, and 2 minus 12x happens to be equal to 0 because we don't want that. So we want that to not equal 0. I put the little line in there. We solve it exactly the same steps and stuff. So we subtract 2 from both sides. So that can't be equal to a -2. So x cannot be equal to 1/6. So because of this condition, we also have to go back to our original set and throw that out. Okay? So I don't want x to be equal to 1/6, which means I have to change this into a parentheses because we don't want to include it. So x for the domain, so for our domain, that's going to be -infinity to 1/6, but it does not include either of those endpoints. It's this second step here that I'm always worried about, okay? So if there's any kind of domain restrictions for the second function, you set the first function equal to that, solve it, and throw those numbers out. You can try to combine it all into one function and stuff, but inevitably what happens is I miss something when I try to do that because I don't think it through fully. So maybe this will help. Certainly hope it does, but if there's anything I need to clarify, please let me know.